multiplying matrices. It is not the same thing. When we added and subtracted, you just added the two numbers that were in the top left corner. It is not that way with multiplying. So the first little thing we're going to talk about is scalar multiplication. A scalar is a number, it's just a single number that you multiply the matrix by. And when you see a number like out in front of a matrix, you just multiply each element by the scalar. So if I ask you to find 3G, you're doing 3 times matrix G and essentially what you're doing is distributing that 3. So we would do 3 times 5, which is what? Yes. 3 times 2? 6. 3 times 9. And 3 times negative 4. Negative 12. Good. That part is, I would say, easy. Yes.
Are you going to see like matrix H plus 3?
You cannot add a single no. You can't add a number to a matrix, but you can multiply by number.
Can you divide?
Yeah. I'm not going to say like G divided by 3, but what I could do is say 1/3 G. 1/3, multiplying by 1/3 is the same as dividing by 3. Multiplying by 1/2 is the same as dividing by 2. Okay. So number 2, negative 2J. So negative 2J is that matrix. And in the calculator, again, it's probably would take you more time to type it in than just to do the math. But you can type in a number and then type in a matrix right beside of it. And it'll do the calculations. Negative 2 times negative 7 is 14. Negative 2 times negative 8, 16. And then 0. Number 3 is 7L minus 5G. So what we're doing is multiplying matrix L by 7, multiplying matrix G by 5, and then subtracting those two matrices. Now, I really didn't leave you enough room to show all of your work, so I'm just going to go ahead and kind of do 7 times L. Okay, so 7 times negative 1 is negative 7. 7 times 5 is 35. Negative 7. And 7 times negative 10, negative 70. Minus 5G. So 5 times 5 is 25. 5 times 2, 5 times 9, 45. And 5 times negative 4, negative 20. And then I can subtract them. Negative 7 minus 25, negative 32. G. 35 minus 10 is 25. Negative 7 minus 45, negative 52, and negative 70 minus negative 20, negative 50. And again, you can type this in the calculator. You can type in a 7 and then matrix L minus 5 matrix G. All right, let's do number 4. Negative 4H. So negative 4 times 3 is negative 12. Negative 4 times 1 is negative 4. Negative 4 times 6 is negative 24. And negative 4 times 10, negative 40. Plus 2L. 2 times negative 1 is negative 2. 2 times 5 is 10. Negative 2. Negative 20. And then when I add those, I get negative 14, 6, negative 26, and negative 60. Any questions? So if you can distribute, that's all this is. Then comes multiplying two matrices by each other. It's not a number times a matrix. It's a matrix times a matrix. And there are some rules to be able to do this. It is different than adding and subtracting. The big rule for adding and subtracting is that both matrices have to have the same dimensions. That's not the case when we multiply. Sometimes, if they have the same dimensions, it doesn't even work at all. Okay, and I'm going to show you how to figure out if it's even possible. If you try to type it in the calculator and it's one that doesn't work, the calculator will give you an error. So it would tell you that it doesn't work. So another thing, when you multiply two matrices, order matters. The order that you write your matrices matters. That's different than multiplying regular numbers. 2 times 3 is the same thing as 3 times 2. But matrix A times B will not give you the same answer as B times A. So the order matters. And then here's the other thing. To multiply, the number of columns in the first matrix must match the number of rows in the second matrix. And there's a really easy way to see that. You don't have to think, okay, number of columns, number of rows. It's really easy. So I'm going to show you how. Matrix A is a 2 by 3 matrix. And B is a 3 by 3. I've put an example here. I want to know if they can be multiplied. So if we want to do A times B, we want to multiply matrix A first times matrix B. What are the dimensions of matrix A? 2 by 3. And B? 3 by 3. You are looking at these middle numbers. You want those middle numbers to match. If the middle numbers match, then yes, you can multiply them. So do they match?
Yes.
Yes, they do. Now, what else is neat is that this also tells us when we multiply them, what size will my answer be? You look at these outside numbers. So my answer will be a 2 by 3 matrix. So this is matrix A, this is matrix B, and I multiply them. If you were to type that in your calculator, your answer would be a 2 by 3 matrix. But what about flipping them? What if I wanted to do B times A? So if I wanted to flip-flop those. What are the dimensions of matrix B? 2 by 3. And A? 2 by 3. Do the middle numbers match? No. So it's not even possible to multiply. Not only would you just get a different answer, in this case, it's not even possible to multiply them. Your calculator would give you an error, and it would say invalid dimensions. The dimensions don't work. So in these 4 examples, we're just going to see if it's possible, and if it is, what are the dimensions of my answer. Alright, so these are referring to the matrices at the top of your page. So G is a what? 2 by 2. H is a 2 by 2. Does it work? Yep. And my answer is it's a 2 by 2. Square matrices, if you take a 3 by 3 times a 3 by 3, you're going to get a 3 by 3. Alright, matrix K is a 1 by 3. M is a 3 by 1. Does it work? Yes, it does. What size will my answer be? 1 by 1. Guess what? If this was the question I gave you to actually multiply out, it's going to be pretty easy. Because your answer only has one element in it. A 1 by 1 is one number. Those would be the easiest problems to do. Is that J? Is somebody else's? Is it J? Sometimes the hole punches aren't on the same spot. So J is a 3 by 1. And M is a 3 by 1. You would think, well, of course, I can do -7 times 6. -8 times -2. But actually, it does not work. You can't do it. J, we said, was a 3 by 1. And K is a 1 by 3. It works. My answer is going to be a 3 by 3. That one. So for a question like this, you would have to do 9 calculations because there's 9 elements. That one you would only have to do 1 calculation because there's only 1 element. Now we're going to see how to actually do it. If I give you 2 matrices to multiply, go ahead and see if it's even possible. If it's not, you're going to waste some time. You're going to get down to it and start working it out and then realize you can't even do it. All right. The number, it has to do with the numbers. So step 2 is just a way to kind of keep you organized, help you not make mistakes. Circle the rows in the first matrix and circle the columns in the second. And we will label them row 1, row 2, column 1, column 2, or however many there are. And then the actual calculations come in next. You're going to do something called the dot product. And you don't know what that is yet, but it's not hard. So the dot product, what you do, if you have 2 lists of numbers, your lists have to have the same amount of numbers in them. Like this one has 3 numbers, that one has 3 numbers. A question where the dimensions don't work out, like a no, you wouldn't have the same amount of numbers in each group. That's why it doesn't work. Right, so the dot product, you take the first 2 numbers and you multiply them. So 1 times 4. Plus, and then you take the second two numbers and multiply them. 2 times 5. Plus the third numbers. 3 times 6. So you multiply the first two numbers, multiply the second numbers, multiply the third numbers, and then add all that together. So what is 1 times 4?
4.
Plus 2 times 5? Plus 3 times 6 is 18. And that gives you what? 32. And you have to do that. So for every element that's in your answer, that's how many times you have to do this. So let's get into a real example. So number 9. First off, let's just go ahead and check to see if it works. So the first matrix is a what? 2 by 3. And the second one is a 3 by 2. Does it work? Yes, it works. And my answer is going to be a what? 2 by 2. Those outside numbers tell us. So I'm going to go ahead and make a matrix that's going to fit my answer. And you don't have to do all this highlighting and stuff. That just helps visual people. So my answer is going to be a 2 by 2. Let's circle the rows in the first matrix. Row 1, row 2. And circle the columns in the second. Column 1, column 2. In my answer, this blank that I've highlighted in yellow, what row is that in?
Row 1.
Row 1. What column?
Column 1.
Column 1. So you're going to do the dot product between our row 1 and column 1, and that answer goes in that blank. Okay. So row 1, the one that I have circled and labeled row 1, 6, -6, -4. I'm going to do the dot product with column 1, 2, 2, -3. And you don't have to show like the 6 times 2. You don't really have a lot of room to do that. So what is 6 times 2? 12. Plus, what's -6 times 2? Yeah, -12. Plus, -4 times -3? +12. And what do you get when you add all three of those numbers together? 12. It is 12. That's funny. And that answer goes right there. Now, this next element is in row 1, column 2. So I'm going to do the dot product between row 1 and column 2. So my row 1, 6, -6, -4. Column 2, -5, 3, 5. Six times -5 is -30. Plus -6 times 3, -18. Plus -4 times 5, -20. And this gives you negative 68. Good. Now my next one, the one I have in blue, that one is row 2, column 1. So row 2 dotted with column 1. One times 2 is 2. Plus negative 6 times 2, negative 12. Plus negative 6 times negative 3, positive 18. And when you add those together, you get 8. The last one is in row, column 2. So 1, negative 6, negative 6, dotted with negative 5, 3, 5. One times negative 5 is negative 5 plus negative 6 times 3 plus negative 6 times 5, negative 30. Negative 53. And then you can check your answer. On the test, I will expect that you do some of these by hand. Well, probably one of them. Negative 68, 8, and negative 53. If one of my 4 numbers was off, it'd be really easy for me to go back and look at the exact space where I messed up and check just that work.
So like if I wanted to say like which numbers to multiply, I'm just trying to make a note to myself in case I forget which numbers, the corresponding numbers, and then add together all the products.
Yeah.
That makes sense to me.
Yeah. I don't know if there's a true word for it. I guess you could say the corresponding elements, maybe. Alright, number 10. We have a 2 by 2 and a 2 by 2. Yes, you can multiply those. What's your answer going to be? 2 by 2. This one will be slightly less work because each dot product, we only have like 2 numbers to do. So if we circle the rows and label them row 1, row 2, and the columns, column 1, column 2. So here what I have in yellow, I'm going to do which row?
1.
Which column?
1.
Yep, row 1 and column 1. We have 5 and negative 1. 5 times negative 1 is negative 5. Plus 6 times 0, 0. Which gives me negative 5. Then we have row number 1 with column number 2. So row 1 and column 2. Five times negative 1 is negative 5. 6 times negative 4, negative 24. Add them together, you get negative 29. See if you can finish this one. Your last two elements should be negative 5 and negative 17. Any questions? We'll do number 11 and then we'll stop. We won't do number 12. So number 11, the first matrix is a 1 by 2. The second one is a 1 by 2. Circle the rows. There's only one. And then the columns. Column 1, column 2. So this one will be easy. So we have row 1 dotted with column 1. And row 1 dotted with column 2. Negative 13 and negative 6.